This is Biddeford High School Graduation Standard A2, graphing linear equations and inequalities in two variables. Okay, so in A1.2 we began graphing inequalities using a number line. In A2 we will be graphing linear equations in two dimensions using a Cartesian coordinate system. Okay, so basically what it is it's just two number lines, one going vertical and one horizontal. Okay, and of course it forms this graph down here. So if we were to take a look at that, this is what it looks like. Okay, so we're going to name these number lines. So the vertical number line is called the y-axis. Okay, right here. It goes all the way up here and all the way down here. Okay, and the horizontal one is the x-axis. More often than not, these number lines will actually be labeled for you. If you notice right here, there's a little y up here, and there's a little x down here. Okay, so the x-axis is the horizontal number line, and the y-axis is the vertical number line. Okay, pause the video if you need more time. Okay. So we can plot coordinates, just a fancy name for points, on this graph by looking at ordered pairs. Okay, these ordered pairs are written as parenthesis x, comma, y, where the first number tells us where to go on the x-axis, and the second number tells us where to go on the y-axis. Okay, so let's take a look at an example. Okay, alright, so as we just said, I'll write it right here. An ordered pair is written as xy, where x represents the x-axis or the horizontal number line, and y represents the vertical number line or the y-axis. Okay, so 2, 3. That means on the x-axis I'm going to go over 2, and on the y-axis from that point I'm going to go up 3. I'll make a point. Okay, negative 1 4, so that means I'll go to negative 1 and I'll go up 4. Negative 2, negative 5, that means I'll go over here 2 and down here 5. And my last one, 3, negative 1, I'll go over 3 and down 1. Okay, so always, 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 we're either going left or right first, then up or down. Okay? So if you notice, this Cartesian coordinate system, or this graph, is broken up into 4 different sections. Okay? This over here is called the first quadrant, or quadrant 1. Over here we have quadrant 2. Down here, quadrant 3. And last, as I'm sure you could guess, we have quadrant 4, written as IB. Okay, so our first coordinate was plotted in the first quadrant. Our second was plotted in the second quadrant. Our third coordinate was plotted in the third quadrant. And last, our fourth point was in the fourth quadrant. Okay, just pause the video if you need more time. Alright, so let's go over our learning targets here. Finally getting into the good stuff. Okay, so level 1, I can recognize when an equation is in one of the forms below. So we'll be dealing with three forms. We have slope-intercept, standard form, and point-slope form. Okay, and if that means nothing to you right now, don't worry, we're just about to go over it. Okay, so let's get set up here. So, what is a linear equation? Okay, so notice the word within linear, and I made a note here, we're not dealing with the word here. Let me circle it, or box it in. Okay, we have the word line there. So what this means, we'll be graphing lines. Okay, so they're given to us using three different equations. Okay, so slope-intercept form is written as y equals mx plus b, okay, where m and b are numbers. Standard form, where we have ax plus by equals c, where a, b, and c are numbers. And our last one, we have point-slope form. Okay, so this one looks a little intimidating. It's really not, though. We have y minus y1 equals m x minus x1. Okay, so in all of these equations, all letters except x and y will be numbers. Okay, so we just introduced the forms there, so level 1, you'll be able to tell when a line is in one of those forms. Okay, so let's take a look at these a little more in depth now. Okay, so for level 2, looks a little dense here, let's go over it. Okay, so I can find the following key components from given equations. So you'd be able to find the slope and y-intercept from a slope-intercept form equation, the x and y-intercepts from a standard form equation, and the slope in any point from a point-slope form equation. Okay? You'll also be able to know how to graph equations of horizontal and vertical lines, identify when a linear inequality has a dotted line or solid line for a border, and also identify points that satisfy an inequality. Okay? And we'll go over all of this during this video. Okay? So, before we start talking about the details about different types of linear equations, let's make one thing clear. All three forms of linear equations that we just talked about, or that have been introduced, all form lines. So it doesn't matter which equation we have, it will always be a line. Always, always. Okay? So all three forms give us a line. So I put this little side note here, okay? Maybe it'll help you remember that we are dealing with lines throughout this entire standard. So think about the following forms, our slope-intercept, standard form, and point-slope form equations. Think about them as, I don't know, Batman, okay? So we know that Batman is Batman, the superhero, but Batman is also Bruce Wayne, okay? So no matter what we call Batman or Bruce Wayne, he is the same person. It doesn't matter which form a line may be in, it will still be the same line. So we will be able to go from point slope form to slope intercept form to standard form, and from all those forms back to the other forms as well. Okay? So they are all the same. Pause if you need more time. Okay, so slope intercept form. Let me write it again. Y equals mx plus b. As we've said a couple times now, m and b are numbers, where y and x will stay in our equation. So we have our slope, which is this m, and we have our y-intercept, which is this b right here. Okay? So in this form, m and b will be numbers. X and y will remain in our equation. So the b, as we just said, is the y-intercept. It tells us where our line crosses the y-axis. So our vertical axis, the y1, whatever this b is where our line will cross the y-axis. Okay? So, for example, if b is 2, we will make our first point at coordinate 0, 2, which means we're going nowhere on the x-axis and we're going up 2 on the y-axis. Okay, if b is -1, we will make our first point at 0, -1. Okay, so staying put on the x-axis, not going anywhere, going down 1 on the y-axis. Okay, the m, also known as the slope, tells us where our next point will be. The slope is written as rise over run. Okay, you'll hear that term a lot as we go through this, where our top number, so our numerator, tells us how far up or down the y-axis our next point will go, so the rise, and the bottom number, or the denominator, tells us how far left or right our next point will go, so the run. Okay, we will assume that a positive number means we go up for rise and right for run. Okay? Negative numbers will make us go the opposite way. If our slope appears to have no denominator, we will say it has a run of 1, because any number divided by 1 equals that number, which is something we talked about in A1.1. Okay, so for example, if I had a slope of 4, we know that can also be written as 4 over 1, so we would go up 4 and to the right 1. Right? So let's take a look at this line. First line. Okay? So what is the y-intercept here? What is our b? Okay, well, first off, let me write the equation. Y equals mx plus b. So our y-intercept, or our b, is where we cross the y-axis. So I'm going to look at this y-axis here and see where this line crosses it. And just by looking at it, I know it crosses right here. So b equals 2. Okay, so from there, let me switch up my color here. So we'll start at this 2 here, okay? And we're going to pick another point, okay? I like to pick where we are dealing with an integer solution here, or integer coordinates, okay? So I'm going to start here at 2, okay? My rise, I go up 3, so I'll put 3, and I go over 2. So I went up 3 units and over 2 units. So my rise was 3 and my run was 2. So I'll just put a little 2 here and I'll put a 3 right here. Okay? So since my slope, or m, equals my rise over my run, I know my slope is 3 over 2. Okay? So our equation, we're just going to plug in our numbers here. So we know that y will stay in our equation and x will stay in our equation. Okay? So b equals 2, so I know I'm going to have plus b. Oh, sorry. I know b equals 2, so I'm not going to have plus b, I'm going to have plus 2. Okay? And for my slope, I'm just going to plug in this 3 over 2. So this is the equation for this line right here. Pause the video if you need more time. Okay, let's take a look at this one. Our standard form equation we know is ax plus by equals c. So this is the standard form equation for a line. Standard form is especially useful in finding intercepts. So intercepts, as we've discussed a little bit so far, are where our line, also known as a function, okay, crosses the x or y axis. So the x-intercept is where a function crosses the x-axis, while the y-intercept is where a function crosses the y-axis. Okay? It's important to note here that in a standard form equation, a, b, and c cannot be fractions. Okay? If they are fractions, we will need to multiply both sides of the equation to get rid of them. And that might be easier to visualize once we do an example. Okay? So, how do we find the x-intercepts? Okay? So, we have two ways of doing this. One, we can look at the graph and see where our function crosses the x-axis. Okay? Or we can set y equal to 0 and solve for x. Okay, so that kind of makes sense, setting y equal to 0 and solving for x in order to solve for the x-intercepts. Because if we look at this graph right here, well, it crosses, our function, or our line, crosses the x-axis at the point 4, 0. Okay, so we're not going up or down on the y-axis. So our y needs to be 0 in order for this function to cross the x-axis at a point. Okay? So, how do we find the y-intercept? So one, we can look at the graph and see where our function crosses the y-axis. Or what we can do, we can set x equal to 0 and solve for y. So again, I know if I am trying to find where our function, or our line in this case, crosses the y-axis, okay, I know it's going to cross the y-axis when x equals 0. Okay? So, what is the x-intercept for this equation? Well, the x-intercept is where it crosses the x-axis, which would be at this point right here. So, the point 4, 0. Okay? And what is the y-intercept? Well, it's this point down here. So we have 0, -2. So what is the slope of this line? So again, I'm going to pick 2 points. I'll pick my 2 circled points here. So I'm going to figure out what my rise is. So from this point, I go up 1, 2, and I go over 1, 2, 3, 4. Okay, so I know my slope, which is m, which is rise over run, equals my rise of 2 and my run of 4, which can be simplified to 1/2. Okay? So, let's move on here. Alright, the last form we'll go over is point-slope form. Okay, so for point-slope form, again, kind of a long equation, but we can break it down. Y minus y1 equals m x minus x1. Okay, so our y1 here is just a y coordinate, and it can be any y coordinate. Our m is our slope, like usual. And our x1 is going to be our x coordinate. Okay, so the point-slope form of a line is very useful when given a graph. Okay, so if you know the slope and you know a point on the line, okay, you can easily find the slope form equation, or the point slope form equation of a line. Okay, so let's hop right into an example. Okay, so let's take a look here. So what is the slope? So we know the slope is m, which is rise over run, which equals, so if I take a look at this, my rise, I'm actually going down, so my rise is going to be -1, okay, and my run, I'm still going to the right, 1, 2, 3, so my run is +3, so I know my slope is -1/3, okay, so let's pick a point. Let's say it could be any point on our line here, okay? So it could be this point up here, it could be this point right here, it could be this point down here. Doesn't matter. So let's say this point right here, okay? So that point is over 3, and we're not going anywhere on the y-axis. So our point is 3, 0, or our coordinate. So what is the point slope form equation for this line? So I'm just going to plug everything in. So I know y is going to stay as y, minus my y coordinate, which is 0, equals m, which is -1/3, parenthesis, x, which I know stays in my equation, minus, and I have a +3 here. So I'll put 3 there. So that's my point slope form equation right there. So let's go over some common questions or scenarios here. So how do we go from point slope form to slope intercept form? All we have to do is distribute our slope and then solve for y. Okay, so I'm given a point slope form equation right here. So I know my slope is 9. So I'll distribute. So I have y minus 4 equals 9x minus 9. And now I'm going to solve for y. So I'll make my t-chart. I'll add 4 to get rid of this -4, which means I have to add 4 over here. So these cancel, so I'm left with y equals 9x, and -9 plus 4 is -5. So we went from a point slope form equation to a slope intercept form equation, just like that. Y equals mx plus b. Great. So how do we go from slope intercept to standard form? So what we're going to do, whoops, we need to get our x and y on the same side of the equation. Then we will get rid of any fractions if need be. Okay, so for an example, let's do the one we just did. So we had y equals 9x minus 5. Okay, so I need it in the form ax plus by equals c. So I'm going to move this 9x over here. So I'll subtract 9x and subtract 9x. So these cancel right here. So I'm left with negative 9x plus y equals negative 5. And what some teachers care about, they don't want a negative a term right here. Okay? I'm not going to be too picky about that. As long as there are no fractions as a, b, or c, I'll be happy. Okay? So how do we go from standard form to slope-intercept form? All we need to do is solve for y. Then we will have an equation in slope-intercept form. Okay? That's really the only difference between the two. Standard form has the x and y on one side and no fractions. Slope-intercept form, we can have fractions, but our y is isolated, or our y is alone. So let's take a look at this in standard form. Let's solve for y. So I'll subtract 4x right here, subtract 4x over here. So these cancel. I'm left with 7y equals negative 4x plus 28. Okay? And you might want to get in the habit of putting your x term before your y-intercept. Okay? So what I'm going to do now, to get this y by itself, I need to divide by 7, which means I need to divide everything by 7. Move it up here. So those 7's cancel, so I'm left with y equals negative 4 over 7x plus 28 divided by 7, which is 4. So I might have mentioned to you during A1.1 solving equations, if we have a fraction, you can just leave it as a fraction, even if it's an improper fraction. Okay? And my reasoning behind that was, right here, we have a fraction. Okay? We have our rise and we have our run. If this were a decimal, it would be a lot harder to figure out what our rise would be and what our run would be. So if we leave it as a fraction, as long as it's simplified, it becomes very easy to figure out what our slope is, or how to graph this. Okay? So, let's take a look at a couple unique examples. So what if we're given a horizontal line? Okay, well, let's try to find our slope. So what is the rise? Okay, well, this function's not going up and it's not going down. It just has a run here. Okay, so what is our rise? It's 0. Okay, it doesn't go up or down. Okay, and what is the run? Okay, well, let's keep going over here, over here, over here. Well, geez, it goes on forever that way, and it goes on forever that way. So our run could be any real number. So what is the slope? So I'll put m equals rise over run. Okay, so our rise is 0, and our run is any number. Okay, so it could be 1, could be -1, could be 100, could be a million, could be -567, could be any number. Okay, so 0 divided by any number is just 0. So that's our slope for this equation. Okay, pause the video if you need more time. So what is the y-intercept for this line? Okay, well, we know it crosses the y-axis at the point 1, 0, or 0, 1, sorry. So we know our b equals 1. So what is the equation of our line? So we'll put in slope-intercept form. Y equals slope of 0, x, plus 1. Okay, and we know 0 times x is just 0. So our line, or the equation for that line, is y equals 1. So now we know that whenever we have a line with y alone, and no variable x, we have a horizontal line through the y-intercept. Great. So, pause the video if you need more time. So, what if we are given a vertical line? Okay, so again, let's try to find the slope. So, what is our rise? So, it goes on forever in this direction, and it goes on forever in this direction. So, our rise is any real number. Okay, and what is the run? It's not going left, and it's not going right, so our run is 0. It doesn't go left or right. Okay, so what is the slope? Well, again, m equals rise over run. Okay, so we know our rise is any number, and our run is 0, which equals undefined. So if you were to take a calculator out right now, and you were to put in any number and divide it by 0, the word error is going to pop up, okay? Because you cannot divide by 0. Okay? So what is the y-intercept? Where does this line cross the y-intercept? Well, it's a line, so it's going to keep going in this direction that way, and keep going in this direction this way. So what is the y-intercept? It doesn't have one. Because it never crosses the y-axis. Okay. Now what is the x-intercept? Where does it cross the x-axis? So take a look at the x-axis here. Okay, and it crosses right here. So at x equals -5. So what is the equation of our line? We're just left with x equals -5. Okay? So now that we know whenever we have a line with x alone, and no variable y, we are left with a vertical line through the x-intercept. Okay? So for levels 1 and levels 2, that's pretty much it for linear equations. Okay? Let's move on to linear inequalities. Okay, so if we think back to A1.1 and A1.2, the only major difference between A1.1, which was solving equations, and A1.2, which was solving inequalities, was the difference in signs and the graphing component. Okay, so graphing linear inequalities is very similar to graphing equations. The only difference is that there is a shading component as well as a difference in lines depending on the situation. Okay? So, by doing this, by shading, and by using different types of lines, so we'll be dealing with dotted lines versus solid lines, okay? This helps us satisfy all solutions for a linear inequality. Okay? So, our first difference here, dotted lines versus solid lines. So the first major difference is how to draw the line. Okay? So if the linear inequality has a greater than or less than sign, we use a dotted line or a dashed line. Okay? If the linear inequality has a greater than or equal to or less than or equal to sign, we use just a regular old solid line. Okay? Remember this. This is very, very important. Okay? The other difference is the shading component. Okay? Because linear inequalities concern a variety of solutions, we must show that we are representing all of the inequality solutions. Okay? So all solutions to a linear inequality can be found by shading the correct side of the line. Okay? And we know which side to shade. By picking test points. Okay? So, how do we know which side? If the point satisfies the inequality, so it makes the inequality true, we will shade the side that the point is on. Okay? If the point does not satisfy the inequality, so it makes the inequality false, we will shade the side the point is not on. Okay? So let's take a look at this example. So we have y is less than negative 6x plus 5. So if we take a look at our sign, we have a less than sign. Okay? And because we have a less than sign, we have a dotted or a dashed line here. Okay? So this side is already shaded over here. But let's prove that this is the correct side. So what I always do for these, I pick easy points. So I could plug in, if I'm trying to pick a point on this side, I could plug in negative 100, negative 100. Okay? But that could leave me with some gross math up here. Okay? So I'm going to make life easy on myself. I'm going to plug in the point 0, 0 right here. Okay? So if I plug it in, I have 0 is less than negative 6 times 0 plus 5. So if I simplify this, I have 0 is less than negative 6 times 0 is 0, and I have plus 5. Is 0 less than 5? It sure is. So that means I will shade the side that the point is on. So 0, 0 is on this side of the line, so I'll shade everywhere over here on this side of the line. Okay? Again, this is already shaded for us. Let's say I were to pick a point, I don't know, 2, 1 right here. So x is 2 and y is 1. So I plug those in. So my y comes down here. Y is less than negative 6 times 2 plus 5. So I do the math. 1 is less than negative 12 plus 5. So 1 is less than negative 7. Is 1 less than negative 7? No, it's not. So because of that, I will shade the side the point is not on. So I pick this point right here, my line's right here. It was false, so I'll shade on this side of the line again. Okay? You do not need to pick 2 points in order to do this. Okay, so if you pick 0, 0 and it happens to work, just shade that side of the line. You don't need to prove that you aren't shading on this side of the line. Okay, this was just an example to show that, let's say you did pick not the wrong side of the line, but the side of the line where the solutions are not, you would just shade on the opposite side. Okay. So our last example here. So we already know where our shading is, so where all our solutions are. So let's pick a point. Let's pick 0, 0 again, because it's easy to work with. Okay, so I have zero is greater than or equal to 7 over 3 times 0 plus 5. Okay, so I do the math. 0 is greater than or equal to 5. 0 is not greater than or equal to 5, so that means I will not shade on this side of the line. I will shade on this side of the line. Okay. This also means that, let's say I wanted to pick the point negative 100, 100, so I'm somewhere way up over here on the graph. Okay. That point would be true. If you were to plug that point into this equation, this inequality would be true. Okay, so let's say I pick negative 3, 0. So this point right here, which I know is a solution because it's already shaded. Okay, so I'll have 0 is greater than or equal to 7/3 times negative 3 plus 5. Okay, so this is the same thing as 0 is greater than or equal to negative 7 plus 5. Okay, because those 3's cancel, we're left with a negative 7. So 0 is greater than or equal to negative 2. 0 is greater than or equal to negative 2. So that means we do shade on this side of the line.